Are you curious about the world of nanotechnology and how it's revolutionizing various industries? Imagine microscopic robots so tiny that thousands could fit on the tip of a needle, working tirelessly to perform tasks beyond our imagination. This might sound like science fiction, but it's closer to reality than you think. Wow! Welcome to the fascinating world of nanorobots. In this video, we're going to demystify this complex technology, break down its working mechanism, and delve into its potential implications on our lives. From medicine to environmental cleanup, these tiny technological marvels are set to make a huge impact. With that said, let's start. What is nanotechnology and how does it work? Nanotechnology is a scientific and engineering discipline focused on the manipulation and utilization of atoms and molecules at the nanoscale, typically measuring 100 nanometers or less. It encompasses the design, fabrication, and application of structures, the devices, and systems with precise control over their properties and functionalities. Nanotechnology works by manipulating and controlling matter at the nanoscale, which involves working with individual atoms and molecules. It utilizes various techniques and approaches to engineer materials, structures, and devices with specific properties and functionalities. By working on such a small scale, nanotechnology offers unique opportunities to explore and exploit the extraordinary properties of materials. Scientists and engineers employ various techniques such as bottom-up and top-down approaches to manipulate and assembled nanoscale components. This enables the creation of new materials with tailored characteristics and behaviors that differ from their bulk counterparts. Now let's talk about nanorobot. What is a nanorobot? Atlanta robot, also known as a nanobot, is a tiny machine or device that operates on the nanoscale, typically measuring in the range of nanometers. These minuscule robots are designed to perform specific tasks at the molecular or cellular level. They are constructed using nanotechnology, which involve manipulating and controlling matter at the atomic and molecular levels. Nanorobotics is an interdisciplinary field that combines the principles of robotics, nanotechnology, and material science to develop robots at the nanoscale. Nanorobotics is an emerging field of science and technology that deals with the design, development, and control of robots at the nanoscale. With that said, here's how it can be used in different fields. Number 1, disease detection and diagnosis. Disease detection and diagnosis, or critical aspects of healthcare, and nanorobots equipped with advanced sensing capabilities have the potential to revolutionize these areas. Where their ability to operate at the molecular level, nanorobots offer a powerful tool for early and accurate detection of diseases, including cancer. Nanorobots can detect specific biomarkers or abnormalities associated with various diseases. These sensors can recognize molecular signatures indicative of disease presence or progression even before symptoms manifest. By analyzing samples at the molecular level, nanorobots can provide highly sensitive and specific diagnostic information, enabling early intervention and treatment. For example, in the case of cancer, nanorobots can be programmed to detect specific tumor markers or genetic mutations that are associated with different types of cancer. They can be introduced into the body to search for these biomarkers and provide real-time information on their presence, location, and concentration. This information can aid and/or early cancer detection, allowing for timely and targeted treatment interventions. Number 2, medical treatment. In medical treatments, nanorobots hold immense promise for revolutionizing patient care. These tiny machines have the potential to perform medical procedures with unparalleled accuracy and precision, surpassing the capabilities of human hands. By leveraging their small size and maneuverability, nanorobots can navigate through the intricate pathways of the human body, reaching targeted sites with remarkable precision. This precision opens up possibilities for minimally invasive surgeries, where nanorobots can access hard-to-reach areas with minimal disruption to surrounding tissues. One of the key advantages of nanorobots is their ability to deliver therapeutics directly to the site of action. With their controlled and targeted drug delivery mechanisms, nanorobots can transport medications with pinpoint accuracy to specific cells or tissues. This targeted approach allows for higher drug concentrations at the desired location, resulting in more effective treatment while minimizing systemic side effects. 6. Furthermore, nanorobots can be engineered to carry out a range of therapeutic functions. For example, they can be designed to selectively destroy cancer cells, precisely delivering anti-cancer agents to tumors while sparing healthy tissues. This targeted approach has the potential to enhance the efficacy of cancer treatments while minimizing the debilitating side effects often associated with traditional chemotherapy. While nanorobots are still in the early stages of development and face numerous challenges, their potential to revolutionize medical treatments is undeniably promising. Number 3, manufacturing and assembly. The potential impact of nanorobots and manufacturing and assembly processes is substantial. These tiny machines offer unparalleled precision and control at the nanoscale, opening up new avenues for creating intricate structures and devices with enhanced properties. functionalities, nanorobots can manipulate and assemble materials at the atomic and molecular levels, allowing for the precise positioning and arrangement of individual building blocks. This level of control enables the fabrication of complex structures and devices that were previously unattainable using conventional manufacturing methods. By harnessing the capabilities of nanorobots, manufacturers can achieve higher levels of efficiency and quality in their production processes. These robots can perform tasks with exceptional precision, reducing errors and variations in product specifications. This leads to improved product consistency, enhanced quality control, and increased customer satisfaction. Moreover, the use of nanorobots in manufacturing can contribute to waste reduction. Their ability to handle and position materials at the nanoscale minimizes material waste and optimizes resource utilization. By precisely depositing materials and assembling components, nanorobots can reduce the need for excess materials and decrease production waste. Worker safety can also be improved through the integration of nanorobots in manufacturing processes. Number 4. Energy production. Nanorobots hold tremendous potential for revolutionizing energy production and addressing critical challenges in this field. Nanorobots can improve the efficiency and performance of solar cells by enhancing light absorption, reducing reflection, and optimizing charge separation and transport processes. They can be used to engineer nanomaterials with tailored properties for more efficient conversion of sunlight into electricity. Contribute to the development of advanced energy storage systems such as batteries and supercapacitors. By manipulating and engineering nanomaterials, nanorobots can enhance energy storage capacity. These improve charge-discharge rate and increase the overall lifespan and reliability of energy storage devices. Nanorobots can aid in the conversion of energy from one form to another. For example, they can be employed in thermoelectric devices to optimize the conversion of waste heat into electricity. By manipulating materials at the nanoscale, nanorobots can enhance the thermoelectric properties of materials, boosting energy conversion efficiencies. Number 5. Environmental cleanup. The application of nanorobots in environmental cleanup presents a promising solution to the pressing challenges of pollution and contamination. These tiny machines have the potential to contribute significantly to the removal of pollutants from water, soil, and air, ultimately aiding in environmental conservation and remediation efforts. In water cleanup, nanorobots can be utilized to target and neutralize various contaminants, including heavy metals, organic pollutants, and harmful microorganisms. They can be engineered with specific functionalities to bind to and remove pollutants from water sources. Additionally, nanorobots can facilitate the process of water purification by enhancing filtration mechanisms and improving the efficiency of water treatment systems. For oil remediation, nanorobots can assist in the removal of toxic substances such as industrial pollutants, pesticides, and chemical residues. They can be designed to break down or encapsulate contaminants, facilitating their removal from the soil and air. Pollution mitigation. Nanorobots can play a vital role in capturing and neutralizing airborne pollutants. They can be deployed to target specific pollutants such as particulate matter, volatile organic compounds, the OCs, or harmful gases. Number 6. Material science. Nanorobots offer exciting possibilities in the field of material science, revolutionizing the development of advanced materials with unique properties and functionalities. Their integration can pave the way for the creation of self-healing materials, smart coatings, and responsive surfaces that adapt to environmental conditions or stimuli. One key application of nanorobots and material science is the development of self-healing material. Nanorobots can be designed to detect and repair damage in materials at the nanoscale. They can autonomously navigate through the material matrix, identify cracks or defects, and initiate healing mechanisms by releasing healing agents or catalyzing chemical reactions. This self-healing capability extends the lifespan of materials, reduces maintenance requirements, and enhances their overall durability and reliability. Smart coatings enabled by nanorobots can revolutionize surface properties and functionalities. Nanorobots can be programmed to respond to specific stimuli such as temperature, light, or chemical changes. By incorporating them into coatings, surfaces can exhibit adaptive properties such as self-cleaning, anti-fouling, anti-corrosion, or anti-icing functionalities. These smart coatings can have broad applications in various industries, including automotive, aerospace, and architecture. Number 7. Exploration and sensing. Nanorobots have the potential to revolutionize exploration and sensing by venturing into challenging and inaccessible environments, providing valuable data and insights that were previously unattainable. Whether it's deep-sea exploration or space missions, nanorobots offer a compact and versatile solution for gathering information and navigating through extreme conditions. In deep-sea exploration, nanorobots can be deployed to explore the depths of the ocean where human access is limited. Equipped with sensors and imaging capabilities, these tiny machines can delve into uncharted territories, mapping the ocean floor, studying marine life, and collecting data on geological formations, their small size allows them to access narrow crevices and fragile ecosystems without causing significant disturbance. Similarly, in space missions, nanorobots can play a crucial role in exploring celestial bodies and conducting research in outer space. They can be utilized to navigate through challenging terrains, collect samples, and perform experiments in environments with extreme temperatures, radiation, or low gravity conditions. Nanorobots can contribute to the study of planetary bodies such as Mars or the Moon, aiding in the search for signs of life. For resources, if you have made it this far, comment down below with the word 100% to confirm that you have received the knowledge from this video. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.